Out there, in the silent, frigid theatre of the cosmos, a great story is unfolding. It is a narrative written in the language of light and gravity, a tale of creation on scales that defy human comprehension. For millennia, we have looked up at the pinpricks of light in the night sky, and we have wondered, what are they? Where did they come from? And from what cosmic crucibles are new ones being forged? We have built ever more powerful eyes to pierce the veil of darkness, extending our senses across gulfs of space and time so profound they strain the very limits of our imagination. From Galileo's first crude lenses to the great mountaintop observatories, each new instrument has pulled back the curtain a little further, revealing a universe more complex and more magnificent than we had ever dreamed. But some secrets remain shrouded, locked away behind impenetrable clouds of cosmic dust, their light too ancient, too stretched by the expansion of the universe for our previous instruments to decipher. To read these lost chapters of cosmic history, we needed a new kind of eye, a technological marvel, a dream decades in the making. We needed a time machine, and so we built one. We call it the James Webb Space Telescope. Stationed 1 million miles from Earth, a solitary sentinel in the cold dark, Webb is the culmination of humanity's collective ambition to know the unknown. Its primary mirror, a breathtaking mosaic of 18 gold-coated hexagons, spans over 21 feet, a giant honeycomb engineered to capture the faintest, most ancient whispers of light from the dawn of time. This is not just a telescope, it is a masterpiece of engineering, a testament to what we can achieve when we dare to ask the biggest questions. Its purpose is revolutionary: to see the unseen, to look back to the cosmic dawn, to witness the birth of the very first stars and galaxies. To accomplish this monumental task, the observatory must be kept unfathomably cold. Heat is the enemy, for the faint infrared light it seeks to detect is itself a form of heat radiation. Any warmth from the telescope itself would be like trying to listen for a pin drop in a thunderstorm. Thus, it is protected by a colossal sun shield, a 5-layered kite of gossamer-thin material the size of a tennis court. On one side, the sun-facing surface bakes at temperatures that could boil water. On the other, just a few feet away, the mirrors and instruments are plunged into a perpetual shadow, chilled to more than 200 degrees below 0 Celsius, colder than any natural temperature found on the surface of the Earth. It is in this extreme cold that Webb's vision becomes preternaturally sharp. And with this vision, it has begun to systematically scan the heavens, peering into corners of the universe previously hidden from us. It is a hunter, searching for the origins of everything we see. And recently, in its patient, silent survey of the deep cosmos, it found something that has sent shockwaves through the astronomical community. It has discovered a place of creation so vast, so violent, and so prolific, it dwarfs anything we have ever witnessed before. Webb has unveiled what can only be described as the largest, most active star factory ever identified in the known universe. The image that came back to Earth was not of a single object, but of an entire ecosystem, a sprawling, turbulent, celestial landscape located billions of light years away, in a distant and ancient corner of the cosmos. Astronomers have provisionally named this colossal structure the Serpent's Heart Nebula, for the winding snake-like filaments of gas and dust that writhe through its core. But this name, poetic as it may be, belies the sheer, unadulterated power of this region. It is less a serene nebula and more a cosmic maelstrom, a continent of creation churning with the raw materials for 1 billion new suns. It is a place where the fundamental forces of the universe are locked in a spectacular battle, a conflict between gravity's relentless pull and the explosive energy of newborn stars. To truly grasp the significance of this finding, we must first journey into the heart of a stellar nursery. Imagine a cloud, but not one of terrestrial water vapour. This is a giant molecular cloud, a colossal accumulation of hydrogen gas and interstellar dust, drifting silently through the void between stars. These clouds are immense, stretching for hundreds of light years. They are profoundly cold, just a few degrees above absolute zero, and they are dark, their dense interiors blocking the light from stars behind them. For millions of years, they can exist in a state of delicate equilibrium, their own gravity trying to pull them inward, while the slight pressure of their gas pushes outward. They are cosmic reservoirs, pregnant with potential. Then something happens to disturb this delicate balance. Perhaps a shock wave from a distant supernova washes over the cloud, or the gravitational nudge from a passing galaxy compresses the gas. Whatever the trigger, pockets within the cloud begin to collapse. Gravity, the silent architect of the cosmos, takes command. Think of it like a crowd of people spread out in a massive field. Slowly, an invisible force begins to gently draw them all toward the center. At first, the movement is barely perceptible. But as they get closer, the pull intensifies and the crowd condenses. Pockets of people become denser, and soon, small, tightly packed groups begin to form all over the field. This is precisely what happens within the molecular cloud. Countless knots of gas and dust, each far more massive than our own solar system, begin to contract under their own weight. These are the seeds of future stars, the protostellar cores. As these cores shrink, the material within them collides, and a crucial transformation takes place. Potential energy is converted into heat. The core begins to warm up, glowing faintly in the infrared spectrum. A protostar is born, a stellar embryo still shrouded in its natal cocoon of gas and dust. This is the phase where the James Webb Space Telescope excels. Its infrared vision can pierce through the obscuring dust, allowing us to witness this critical, formative stage for the very first time with such clarity. Around the nascent star, the remaining material flattens into a rotating disk, an accretion disk that looks like a miniature version of a galaxy. From this swirling platter of dust and gas, the protostar will continue to feed, growing more massive and hotter over hundreds of thousands of years. It is within these protoplanetary disks that future worlds will be built, as tiny dust grains stick together, growing into pebbles, then boulders, and eventually planets. But the central star has its own destiny to fulfill. Deep within its core, the pressure and temperature are building to unimaginable levels. Finally, a threshold is crossed. The core becomes so hot and dense, millions of degrees, that hydrogen atoms are forced to slam together with such violence that they fuse, forming helium in a process called thermonuclear fusion. This is the moment of ignition. It is the instant a celestial object ceases to be a mere ball of gas and becomes a true star. A tremendous wave of energy is unleashed from the core, pushing outward with incredible force. This outward radiation pressure is what halts the star's gravitational collapse. The star stabilizes, entering a long and stable period of its life, a luminous sphere in a perfect self-regulating balance between gravity pulling in and fusion pushing out. It has joined the grand cosmic tapestry as a point of light, a furnace that will burn for billions of years, creating heavier elements and bathing any surrounding planets in life-giving energy. Now, take this intricate, beautiful process and multiply it by 1,000,000. Take the energy, the scale, and the sheer creative force and amplify it 1,000-fold. This is what is happening inside the Serpent's Heart Nebula. It is not simply forming a few stars or even a few dozen. It is a starburst region of unprecedented ferocity. Our own Milky Way galaxy is a relatively quiet place. On average, it transforms about 1 to 3 solar masses of gas into new stars each year. It is a slow, steady production line. The Orion Nebula, one of the most famous and active stellar nurseries in our galactic neighbourhood, is a marvel of creation we can see with backyard telescopes. It is a cosmic workshop crafting a cluster of brilliant young suns. The Serpent's Heart, however, is not a workshop. It is a continental-scale industrial complex operating in overdrive. Early estimates from the Webb data suggest this region is producing stars at a rate hundreds, perhaps even thousands of times greater than our entire galaxy. It is a singular location of such intense creation that it will single-handedly shape the evolution of its host galaxy. When astronomers first processed the images, they were astounded. Webb's unparalleled resolution revealed a scene of breathtaking complexity and violence. What they saw was not a placid cloud, but a churning, frothing sea of gas. There are vast caverns hollowed out by the intense radiation and powerful stellar winds from legions of massive young stars that have already ignited. These newborn giants, many dozens of times more massive than our Sun, burn with a brilliant blue-white intensity. They are cosmic disruptors. Their ferocious ultraviolet radiation ionizes the surrounding hydrogen gas, causing it to glow in spectacular hues of red and pink, creating what we call an emission nebula. The visuals are simply staggering. Imagine vast shimmering curtains of light, like a cosmic aurora borealis, draped across structures hundreds of light years wide. But these stars do more than just illuminate the cloud. They actively reshape it. Their stellar winds, streams of charged particles moving at millions of miles per hour, act like a snowplow, bulldozing the gas and dust into dense ridges and pillars. This is creation and destruction in a delicate dance. The very stars being born are simultaneously compressing new regions of the cloud, triggering fresh waves of gravitational collapse and birthing yet another generation of stars, while also blasting away the raw material needed for future star formation. Webb's images show these pillars of creation in haunting detail. They stand like colossal celestial mesas, silhouetted against the glowing backdrop of ionized gas. At their very tips, where the gas is most compressed, Webb's infrared eyes can see the telltale glow of embryonic stars still gestating within their dusty wombs. It is a complete, self-contained ecosystem of birth. We are seeing the past, present, and future of star formation all within a single frame. We see the dark, cold filaments of gas, the raw materials yet to collapse. We see the bright infrared points of protostars about to ignite, and we see the brilliant, massive stars that have already burst forth, now dominating and reshaping their environment. So, the question becomes, why here? What makes the Serpent's Heart so uniquely fertile? The answer likely lies in its environment. This nebula is not an isolated cloud drifting peacefully through intergalactic space. It is situated at the heart of what appears to be a galactic merger in progress, or a protocluster of galaxies in the early universe. When galaxies collide, it is an event of unimaginable scale and grandeur. Individual stars rarely, if ever, hit each other due to the vast distances between them. But the immense clouds of gas and dust within the galaxies are another matter entirely. As two galaxies pass through each other, their gas clouds slam together, compressing the material on a galactic scale and triggering a firestorm of star formation. This is known as a starburst galaxy. The Serpent's Heart appears to be the epicenter of one such cataclysmic event. It is the supercharged engine room of a forming galactic titan. The sheer volume of raw material available is staggering, and the constant gravitational disruption from the merger is acting as a relentless trigger, squeezing the gas and initiating gravitational collapse on a scale we've never seen before. This discovery fundamentally challenges and refines our understanding of how galaxies grow and evolve. Cosmological models had predicted that such intense regions of star formation existed in the early universe, but they were largely theoretical, shrouded by distance and dust. Now, Webb has not only confirmed their existence, but has revealed their inner workings with a clarity that was previously the stuff of science fiction. By studying the light from this region, scientists can do more than just see the stars. They can analyze it, breaking it down into its constituent wavelengths using spectroscopy. This allows them to read the chemical fingerprint of the gas. They can determine its composition, its temperature, its density, and its motion. Early analysis from Webb's spectrographs suggests that the gas in the Serpent's Heart is chemically less enriched than the gas in our own galaxy. This makes sense, as we are looking far back in time, to an era before countless generations of stars had a chance to forge heavier elements and spew them into space. We are seeing a more primordial form of creation, drawing from a gas mixture closer to that produced by the Big Bang itself, mostly hydrogen and helium. This has profound implications for the kinds of stars being born there. In an environment with fewer heavy elements, the gas clouds cool less efficiently. This can lead to the formation of much more massive stars than are typically born today. The Serpent's Heart may be a factory for monsters, stars that are 100, 150, or even 200 times the mass of our Sun. These stellar behemoths live fast and die young. They burn through their nuclear fuel in a mere few million years, compared to the 10 billion year lifespan of a star like our Sun. And when they die, they don't fade away quietly. They detonate in the most powerful explosions the universe has to offer, supernovae, or, in the case of the most massive stars, hypernovae. The end of such a star's life is an event of cosmic significance. In its final cataclysmic explosion, it outshines its entire host galaxy. For a few weeks, it can be the brightest object for billions of light years in any direction. But more importantly, this explosion forges and disseminates all the heavy elements that were created in the star's core during its lifetime. Elements like oxygen, which we breathe, carbon, the backbone of life, iron, which flows through our veins, silicon, which makes up the rock beneath our feet. These elements, essential for planets and for life as we know it, are manufactured in the hearts of massive stars and distributed throughout the cosmos by their explosive deaths. The Serpent's Heart, therefore, is not just a star factory. It is an element factory on an industrial scale. The sheer number of massive stars being produced within it means that in a few million years, this entire region will be rocked by a cascade of supernova explosions. It will become one of the most violent and dangerous places in the universe, but also one of the most chemically creative. It is seeding its galaxy with the building blocks for future generations of stars, planets, and just maybe, life. The discovery connects us in the most direct way imaginable to the distant cosmos. The very atoms that constitute our bodies, our planet and our sun, were forged in a place like this, billions of years ago, in the fiery heart of a long-dead massive star. When we look at the image of the Serpent's Heart, we're not looking at something alien and separate from us. We are looking at our own origin story, writ large across the canvas of space-time. This monumental discovery opens up a whole new realm of questions for science. It provides a perfect laboratory for testing our theories of star formation under the most extreme conditions. How exactly does the feedback from massive stars regulate the birth of new ones? Can a starburst of this intensity eventually quench itself by blowing away all the available gas? What kinds of planetary systems will form around the smaller, longer-lived stars born in such a turbulent environment? Will they be richer in heavy elements thanks to their massive, short-lived neighbours? The data streaming back from Webb is a treasure trove that will keep astronomers and astrophysicists busy for decades to come, building new models and refining our picture of the universe. The path to this moment was not easy. It was paved with decades of struggle, innovation, and unwavering dedication from thousands of scientists, engineers, and technicians. The James Webb Space Telescope project pushed the boundaries of what was technologically possible. There were budget overruns, delays, and moments when the entire endeavour seemed on the brink of failure. The complexity of deploying a telescope of this size in the vacuum of space, unfolding its delicate mirrors and sunshield flawlessly, was an engineering challenge of historic proportions. The world watched, holding its breath, as each step of the deployment was successfully completed 1 million miles away. The relief and elation in mission control was a profound moment for science, a triumph of human ingenuity and perseverance, and this discovery of the universe's grandest stellar nursery is the ultimate vindication of that effort. It is the fulfillment of the promise that if we could just build an eye sharp enough, sensitive enough, and capable of seeing the right kind of light, the universe would reveal wonders that would rewrite our textbooks. The Serpent's Heart is more than just a scientific object. It is a source of awe and wonder. It is a cosmic work of art painted with glowing gas and dark dust, sculpted by the interplay of gravity and light. It reminds us of the sheer scale of the universe in which we live. Our entire solar system would be an invisible speck within a single tendril of this nebula. Our entire galaxy, the Milky Way, with its hundreds of billions of stars, is just one of many, engaged in a cosmic dance of creation and destruction. What will become of this magnificent structure? Over the next few 100 million years, the intense burst of star formation will likely subside. The gas will be consumed or blown away by the barrage of supernovae. The turbulence will calm. Turbulence. What will be left behind is a legacy of stars, a massive young globular cluster, or perhaps the central core of a new giant elliptical galaxy, populated by the tens of millions of stars born in this single spectacular event. The serpent's heart will fade, its fires will die down, but its children, the stars it created, will shine on for billions, even trillions of years, carrying within them the chemical legacy of their violent birthplace. And as for us, we continue to watch. The James Webb Space Telescope will continue its silent vigil, peering deeper into the darkness, further back in time. What other secrets are waiting to be uncovered? What other cosmic factories, ancient galaxies, or nascent solar systems are hidden just beyond our view? This discovery is not an endpoint. It is a new beginning. It has opened a door to the early formative universe that we're only now beginning to step through. It reaffirms our place in the cosmos not as passive observers, but as active participants in the universe's grand quest to understand itself. We are a collection of stardust, animated by curiosity, and with instruments like Webb, we are extending our minds and our senses into the farthest reaches of reality. The light from the Serpent's Heart Nebula began its journey long before our planet even formed. It travelled across the expanding universe for billions of years, a silent messenger from a bygone epoch, and it has finally arrived here at a gold-coated mirror 1,000,000 miles from Earth, to be captured and translated into a language we can understand. It is a message that tells us that the universe is not a static, empty place. It is a dynamic, evolving, and relentlessly creative entity. It is a place of unimaginable beauty and power, a place where from darkness and dust, new light is eternally being born. And our journey to comprehend it has only just begun. Look out into the deepest expanse of the cosmos. Out there in the silent velvet darkness between the stars lurk objects of such profound and baffling strangeness they challenge the very limits of our imagination. They are the universe's ultimate monsters, points of infinite density where the laws of physics break down, places where reality itself is torn asunder. We call them black holes, and they present us with a paradox so fundamental it seems to shatter our understanding of the universe. A question that once asked is impossible to ignore. If absolutely nothing, not even the fastest thing in existence, not a single particle of light can escape a black hole's grasp, then how can its gravity, how does its colossal influence reach out across light years to hold stars in its sway to anchor entire galaxies? If the prison is perfect, if the gates are sealed forever, how does the jailer's command get out? This simple question is a key. It unlocks a truth about the cosmos, far stranger and far more elegant than you have ever been told. It is a journey that will force us to redefine the very nature of space-time and gravity itself. To begin, we must travel to the edge of the abyss. Imagine yourself in a starship drifting through interstellar space. Before you, a swirling incandescent disk of superheated gas and dust, a cosmic whirlpool of stolen light and shredded stars. At its center there is nothing, a perfect circle of absolute blackness, a hole punched in the fabric of reality. This is the event horizon. It is not a physical surface you could touch. There is no wall, no membrane, no signpost that reads "turn back." It is a boundary of pure geometry, a line defined by a single terrifying law. From this point forward, all paths lead to the center. There are no other possible destinations in space-time. The future of anything that crosses this threshold is a one-way trip to the singularity at the heart of the void. Now consider the nature of light. It is the universe's ultimate speedster, its absolute speed limit, 300,000 kilometers per second. A velocity so immense it could circle the Earth more than 7 times in the blink of an eye. In our everyday experience, its speed feels infinite, instantaneous. It is the fastest signal, the quickest messenger, the most rapid escape artist the cosmos has ever produced. And yet, at the event horizon, it is brought to a complete halt. A photon of light born from the fiery chaos of the accretion disk might try to flee outward away from the darkness, but space-time itself is flowing inward into the black hole faster than light can travel outward. It is like a swimmer fighting against an unstoppable cosmic waterfall. No matter how fast they paddle, they are carried inexorably over the edge. Light, the very symbol of cosmic freedom and speed, is trapped. Its messages from beyond the horizon are silenced forever. This is the core of the problem, the heart of the contradiction. If no information, no signal, no particle of any kind can break free from this gravitational prison, then the black hole should be utterly isolated from the universe. It should be a silent, invisible phantom, its existence only betrayed by the hole it leaves in the stellar backdrop. It should have no more influence on the outside world than a prisoner in a sealed dungeon has on a kingdom miles away. But that is not what we see. We look at the center of our own Milky Way galaxy, and we witness giant ancient stars, some larger than our sun, whipping through space at breathtaking velocities. They perform an intricate, invisible ballet orbiting a point of utter blackness with clockwork precision. That central point, Sagittarius A star, is a supermassive black hole. Its influence is undeniable, its dominion absolute. It holds our galaxy's core together. We see galaxies locked in a gravitational dance, their shapes distorted by the unseen presence of these titans. We see light from distant quasars bent and warped its path, diverted by a gravitational titan's invisible hand. This is the evidence. This is the cosmic crime scene. The fingerprints of the black hole are all over the universe. Its pull, its command, its gravitational shout is clearly being heard across unimaginable distances. So the paradox deepens. The silence from within the event horizon is absolute, and yet the gravitational roar outside of it is deafening. How can a collapsed star shrouded in a cloak of permanent silence still dictate the motions of a star a trillion kilometers away? Is there some secret messenger, some unknown particle that is faster than light, able to escape the abyss and carry the news of the black hole's gravity? The answer is no. The laws of physics as we understand them are not being broken. Our assumptions are. The flaw lies in the very question we are asking. It's hidden in that single deceptive word escape. When we think of a force, we intuitively picture something moving. We imagine rays of light radiating from a lamp. We picture magnetic field lines flowing from a magnet. We think of particles of waves of information traveling from a source across space to a target. This is the universe, as Isaac Newton described it. A grand cosmic clockwork of forces and actions, of pushes and pulls across the empty stage of space. In this Newtonian view, gravity is a force, a mysterious, invisible tether reaching out from an object, grabbing onto another and pulling it close. If this were true, then gravity would indeed need a messenger. Some kind of graviton, a particle that would have to constantly stream out of the black hole, cross the event horizon and tell the surrounding universe, I'm here, I have this much mass, pull this way, and that of course would be impossible. That messenger, like light, would be trapped. The tether would be cut. The connection would be severed. For centuries, this Newtonian vision of gravity was enough. It described the fall of an apple and the orbit of the moon, but it couldn't explain everything, and it certainly couldn't make sense of a black hole. To solve our paradox, we must leave this familiar world behind. We have to tear up the old maps and embrace a new cartography of the cosmos. A vision of reality imagined by a single mind a century ago, a reality conceived by Albert Einstein. Einstein gave us a new language to describe the universe, and in this new language, gravity is not a force at all. It is not a mysterious tether reaching across the void. Gravity, he revealed, is a consequence. It is the outcome of something far more fundamental, the shape of the universe itself. He asked us to imagine that space is not just an empty stage, and that time is not just the ticking of a universal clock. He asked us to see them woven together into a single dynamic entity, a four-dimensional fabric space-time, This cosmic tapestry is not passive, it is active. It can be bent, stretched, warped, and twisted. And the cause of this warping is mass and energy. Think of it like a perfectly flat, taut rubber sheet stretching out to infinity in all directions. Now place a bowling ball in the center of that sheet. The sheet curves. It sags under the weight of the ball. The fabric of our metaphorical universe is now distorted. The geometry is no longer flat. Now roll a small marble nearby. The marble doesn't feel a force pulling it toward the bowling ball. It simply follows the easiest, most direct path available to it. But that path is no longer a straight line. The path is now curved because the very space it is traveling through has been bent by the presence of the larger mass. The marble spirals inward, orbiting the depression in the sheet, not because it is being pulled, but because it is following the contours of the warped geometry. This, Einstein declared, is gravity. It is the curvature of space-time. An object with mass does not send out a signal. It does not broadcast a force. It simply, by its very existence, alters the geometry of the universe around it. It creates a depression, a valley, a well in the fabric of space-time, and other objects moving through that region of space simply follow the contours of that well. The Earth is not being pulled by the sun. It is rolling along a vast circular valley in space-time, carved by the sun's immense mass. We are not tethered to our planet by an invisible rope. We are held in a gentle depression in the cosmic fabric, a shallow dip created by the Earth's presence. Now, let us return to our monster, our black hole. What happens when we apply this new understanding? A black hole is not just a bowling ball on the rubber sheet. It is an object of such extreme density, such concentrated mass, that it has punched a hole clean through the fabric. It has created a well with no bottom, a depression of infinite steepness. The event horizon is the rim of this bottomless pit. It is the point where the slope becomes so vertical that any path you take leads only downward into the singularity. So when a star orbits a black hole, it is not responding to a signal that has managed to miraculously escape from inside the event horizon. It is responding to the profound, enduring shape of the well that exists far outside the event horizon. The gravity felt by that star is the geometry of the space it occupies. The distortion, the curvature, the vast cosmic slope was created by the mass of the original star long before it collapsed. The gravitational field we witness is a permanent echo. It is a fossilized imprint of the object's mass, forever frozen into the structure of space-time itself. Think of it this way. Imagine a powerful vortex of water swirling in a river. A boat caught in the current will be pulled inexorably toward the center. The boat is responding to the shape of the water, the flow of the current. It doesn't need a message from the object at the bottom that created the whirlpool in the first place. The whirlpool's influence, its shape, its power, is a persistent feature of the river itself. The black hole is the cause, but the curved space-time is the effect. And that effect extends outward, far beyond the point of no return. So when we ask, how does gravity get out? We are speaking the wrong language. We are asking the wrong question. It's like standing on the slope of a great mountain and asking, how does the mountain's downhillness escape from its peak to tell me which way to fall? The question is nonsensical. The slope, the downhillness, is a property of the mountain's shape. It is the geometry of the ground you are standing on. It doesn't need to travel anywhere. It is simply there. The gravitational field of a black hole is not inside it. It is the very shape of the space-time outside it. It is the architecture of the prison, not another prisoner. It is a static, unchanging map of distorted reality, a permanent consequence of the mass that is now lost to our view. The mass is inside the event horizon. The curvature it creates is outside. And that curvature is the gravity we can see and measure. This profound shift in perspective changes everything. It transforms gravity from a mysterious, invisible action at a distance into the very fabric of the cosmos we inhabit. We live, move, and have our being within a four-dimensional ocean, and the currents and tides of that ocean are what we perceive as gravity. A black hole is the ultimate maelstrom in this cosmic sea, a place where the currents become infinitely strong, pulling the fabric of reality itself down into a singular point. So the paradox is resolved, not by discovering a new particle or a new force that can defy the laws of physics, but by a complete and total revolution in our understanding. Light is a traveler through space-time, and when that space-time becomes a one-way street, light is trapped. But gravity is the shape of that one-way street. It is the road itself, not a car trying to drive on it. It cannot be trapped for the simple reason it was never trying to go anywhere. This distinction is the key that unlocks the secrets of the universe's most enigmatic and powerful creations. It allows us to comprehend how an object utterly sealed off from the rest of the cosmos can still command galaxies. It reveals a universe more subtle, more interconnected, and more profoundly bizarre than our ancestors ever dreamed. The question was never about escape. It was about the fundamental nature of existence. And the answer tells us that we are all right now, moving through the invisible contours and valleys of a universe shaped by the ghosts of long-dead stars. The pull we feel is the echo of their ancient mass, a whisper of gravity written into the geometry of forever. Right now you are being held. An invisible, silent and relentless presence is keeping you in your chair, anchoring you to a planet that is itself tethered to a star, which is in turn bound to the slow, majestic waltz of a galaxy. This is the tyranny of gravity. It is the most familiar and fundamental feature of our existence, the great cosmic organizer, the architect of worlds and stars. Yet it is also the deepest of mysteries. For centuries we thought we understood its grasp. We gave it a name, wrote its laws, and used them to chart the heavens, believing we had tamed the cosmos with our reason. But we were mistaken. Our journey to comprehend this elemental grip on reality would lead us to a place where all our intuition fails, a place where the universe is twisted into an impossible knot, a place where light itself, the fastest thing in existence, is brought to a final permanent halt. It would lead us to the black hole, and here at the edge of the ultimate abyss, a paradox emerges, a cosmic contradiction so profound it threatens to unravel everything we think we know about the universe. If a black hole is a perfect prison, a one-way door from which nothing can ever return, how does its gravity escape? How can a captive command an empire? To find the answer, we must first travel back in time, back to a world lit by gas lamps and powered by steam. A world where the universe was seen as a grand, predictable clockwork wound by the hand of a divine watchmaker, and its master blueprints were written by one man, Isaac Newton. His story is legendary, perhaps even mythical. An apple falls, a mind ignites. But what was born in that moment was more than a simple insight. It was the first truly universal law. Before Newton, the heavens and the earth were two separate realms governed by different rules. The celestial spheres moved in perfect ethereal circles, while terrestrial objects simply fell crudely and without grace. Newton demolished that wall with a single elegant equation. He declared that the very same influence that pulls an apple to the ground is the one that holds the moon in its orbit around the Earth. It is the same cosmic leash that keeps the Earth chained to the Sunday. It was everywhere, it was instantaneous, and it acted on everything. He called it a force, an invisible attraction between any two objects with mass, a kind of cosmic magnetism pulling all things together. The more massive the objects, the stronger the pull. The farther apart they were, the weaker it became. This was a revolution in human thought. Suddenly the universe was not a chaotic mystery, but a solvable problem, a celestial machine of exquisite precision. Using Newton's laws, we could predict the return of comets with astonishing accuracy. We could explain the rhythmic swell and fall of the tides. We could even discover a new planet Neptune by noticing a subtle wobble in the orbit of Uranus, a ghostly tug from an unseen world, its position calculated on paper before it was ever seen through a telescope. Newton's gravity was a triumph. It gave humanity a sense of mastery over the cosmos. The universe, it seemed, played by a set of rules we could understand. Yet even Newton himself was deeply troubled by his own creation. He could describe how gravity worked with mathematical perfection, but he could not explain why. How did the sun 93 million miles away reach out across the vacuum of space and instantly command the Earth to follow its path? How did one object know another was there? This action at a distance, as he called it, seemed like magic, an occult phenomenon smuggled into the heart of his rational science. He had written the script for the cosmic ballet, but the dancer itself remained a ghost, a phantom force acting without any medium, without any delay. For over 200 years, this ghost haunted physics. Newton's laws worked so perfectly that we learned to ignore their strange, seemingly supernatural foundation. The clockwork universe ran smoothly, and we were content until it didn't. The first clue that something was profoundly wrong with our understanding lay at the very heart of our own solar system. It was a tiny, infuriating discrepancy in the orbit of Mercury, the planet closest to the Sun. According to Newton's pristine equations, the planets should trace perfect ellipses around the Sun, repeating their paths for eternity. But Mercury refused to cooperate. Its elliptical orbit wasn't fixed in space. Instead, it was slowly, stubbornly precessing. Imagine drawing an ellipse and then slowly rotating the entire drawing. This was Mercury's motion, a slow pivot of about 1 degree every 7,000 years. It was a minuscule error, a cosmic rounding error. But in a universe supposed to run with the precision of a Swiss watch, it was an unacceptable flaw. Astronomers were frantic. They invoked phantom planets hidden between Mercury and the Sun, whose gravity could explain the wobble. They called this hypothetical world Vulcan. They searched for it for decades. But Vulcan was never found. The ghost was not another planet. The ghost was in the theory itself. Newton's masterpiece, the bedrock of physics, for 2 centuries had a crack in its foundation. The universe was not a perfect clockwork. It was something stranger, something deeper, and it would take a new kind of mind to see it. Not an astronomer peering through a telescope, but a patent clerk in Switzerland dreaming in his chair. Albert Einstein. He began not by looking at the stars, but by conducting experiments in the laboratory of his own imagination. He asked simple, almost childish questions that would ultimately overthrow our entire conception of reality. What if you were in an elevator in deep space, far from any planet or star? You would be weightless, floating freely. Now, what if a cable began pulling your elevator upwards, accelerating it at a steady rate? You would feel a force pressing you to the floor. Your feet would be planted firmly. If you dropped a ball, it would fall to the floor just as it does on Earth. From inside your windowless box, you would have no way of knowing whether you were being pulled up by a rocket in space or sitting perfectly still on the surface of the Earth. The experience of acceleration and the experience of gravity were, he realized, indistinguishable. This was his happiest thought, the principle of equivalence. Gravity was not some mysterious, instantaneous force reaching across space. It was something far more intimate, woven into the very nature of space and time itself. This was the first step toward a complete demolition of Newton's universe. Einstein's next leap was even more audacious. He had already shown with his theory of special relativity that space and time were not separate, absolute, and unchanging concepts. They were inextricably linked in a single 4-dimensional continuum space-time. This is the arena in which all events in the universe unfold. It is the stage for reality. For Newton, this stage was flat, rigid, and passive. a backdrop against which the drama of matter and forces played out. But Einstein proposed something astonishing. The stage itself was an active participant in the cosmic drama. He argued that the presence of mass and energy does not create a force. Instead, it fundamentally alters the geometry of the universe around it. Mass and energy tell spacetime how to curve, and the curvature of spacetime tells mass and energy how to move. This is the heart of general relativity. Gravity is geometry. The classic analogy is a rubber sheet stretched taut. This flat sheet represents spacetime empty and undisturbed. Place a bowling ball in the center. The sheet warps, sags, creating a deep well in the fabric. This is what a massive object like the Sun does to spacetime. It creates a gravitational well. Now roll a small marble representing a planet like Earth across the sheet. The marble isn't being pulled by the bowling ball. There is no invisible string connecting them. The marble is simply following the straightest possible path through the now curved surface. It tries to move in a straight line, but the very fabric it travels on is bent, forcing it into an orbital path. The Earth is not being pulled by the Sun's force. The Earth is free-falling through the warped spacetime created by the Sunday. You, sitting in your chair, are not being pulled down by a force. The mass of the Earth has curved the spacetime around you, and the chair is simply preventing you from following the natural downward slope of that curve. This was not just a philosophical reframing, it made concrete, testable predictions. And the first puzzle it solved was the stubborn orbit of Mercury. The Sun is so massive that the spacetime nearest to it is severely warped. As Mercury plows through this heavily distorted region of the cosmos, its path is guided along the contorted geometry. When Einstein calculated Mercury's orbit using his new equations, the precession, the slow, anomalous pivot, matched observation perfectly. The ghost in the machine was vanquished. The flaw in the blueprint was fixed. Newton's force was an illusion, a shadow of a deeper truth. But Einstein's theory made an even more bizarre prediction. If mass curves spacetime and everything has to follow that curvature, then this rule must apply not just to planets and apples, but to everything that travels through the universe. Even light. A beam of light, the very definition of a straight line, should bend as it passes by a massive object. This was a wild, audacious claim. How could you possibly test it? You cannot see stars in the daytime when they are near the sun in the sky, but there is one exception during a total solar eclipse. In 1919, the British astronomer Arthur Eddington led expeditions to Brazil and an island off the coast of Africa. Their mission was to photograph the field of stars around the sun the moment it was blotted out by the moon. If Einstein was right, the apparent positions of the stars just beyond the sun's limb would be shifted slightly, their light deflected by the sun's immense gravitational well. As the world went dark in the middle of the day, the photographic plates were exposed. Weeks later, after painstaking analysis, the results came in. The starlight had bent, and it had bent by the exact amount Einstein's equations predicted. It was a staggering confirmation. The news flashed around the world. A new vision of the cosmos was born. A universe not of forces and empty voids, but of a dynamic, malleable fabric, a cosmic landscape of hills and valleys sculpted by matter and energy. Gravity was no longer a phantom, it was the shape of the universe itself, and this new understanding of gravity would lead us inevitably to a prediction so monstrous, so seemingly absurd, that even Einstein himself couldn't believe it was true. It would lead us to a place where the curvature of spacetime becomes infinite. Our universe is filled with stars, titanic nuclear furnaces fusing hydrogen into helium in their cores. For millions or billions of years they exist in a delicate balance. The outward pressure from the nuclear fusion in their heart perfectly counteracts the inward crush of their own immense gravity. But this balance cannot last forever. The fuel will eventually run out. For a star like our Sun, the end will be relatively gentle. It will swell into a red giant, then slowly fade into a white dwarf, a cooling, planet-sized cinder. But for stars much more massive than our Sun, the end is catastrophic. When their fuel is spent, the outward pressure vanishes in an instant. Gravity, the relentless crusher, finally wins, and it wins decisively. The star's core collapses in on itself in a fraction of a second. The outer layers rebound against this impossibly dense core, triggering a supernova, one of the most violent events in the cosmos. A single star can briefly outshine its entire host galaxy, forging and scattering the heavy elements that make planets and life possible. But what of the core that remains? If the original star was massive enough, nothing in the known universe can stop the collapse. No force can stand against the ultimate triumph of gravity. The star's remnant continues to shrink, crushed past the density of an atomic nucleus, past any state of matter we can comprehend. Think of escape velocity. On Earth, you need to launch a rocket at about 25,000 miles per hour to escape our planet's gravitational pull. From the surface of the Sun, you'd need to travel over 1 million miles per hour. Now imagine squeezing the entire mass of the Sun into a sphere just a few miles across. The escape velocity from this object would be astronomical. Squeeze it even further, and the escape velocity climbs higher and higher. The collapsing stellar core is undergoing this exact process. As its mass is compressed into an ever smaller volume, the curvature of space-time around it becomes steeper and steeper. The gravitational well becomes a bottomless pit. Eventually, a threshold is crossed. A point of no return. The core is crushed into a point of zero volume and infinite density. A singularity. Here, our laws of physics break down entirely. It is a place where space and time as we know them cease to exist. And surrounding this point of finality is a boundary, a one-way membrane in the fabric of reality itself. This boundary is the event horizon. It is not a physical surface you could touch. It is a purely geometric frontier. It is the precise distance from the singularity where the curvature of space-time becomes so extreme that the escape velocity exceeds the speed of light. Since nothing can travel faster than light, nothing that crosses this threshold can ever get back out. It is the ultimate prison wall. Imagine a powerful swimmer in a river that is flowing gently. They can easily swim upstream against the current, but as the river narrows and quickens approaching a waterfall, the swimmer has to work harder and harder just to stay in place. At some point, they cross an invisible line where the water is moving faster than they can possibly swim. From that moment on, their fate is sealed. No matter how hard they struggle, the current will carry them over the falls. The event horizon is that line for space-time itself. Inside the horizon, space-time is flowing inward toward the singularity faster than the speed of light. Any particle, any ray of light is like a swimmer caught in that unstoppable current. It tries to travel outward, but the very fabric of reality it exists within is being dragged inward at a superluminal speed. The path to the outside universe has ceased to exist. The exit door is gone. This is a black hole. Not a hole in the conventional sense, but a region of space-time so profoundly warped that it has cordoned itself off from the rest of the universe. It is an abyss that swallows everything: matter, energy, information, and most importantly, it swallows light. It is the color black, not because it is dark, but because any light that enters it can never leave to reach our eyes. It is a complete information void, a cosmic dead end. For decades, they were just a theoretical curiosity, a ghost in Einstein's equations. But today, we have seen them. We have detected the gravitational waves, the ripples in space-time itself from two black holes spiraling together and merging. We have photographed the shadow one casts against the brilliant incandescent gas swirling around its event horizon. They are real, and they are everywhere, lurking in the centers of galaxies, including our own. So we have arrived at the edge of the abyss. We have traced the history of an idea from Newton's apple to Einstein's curved spacetime to the ultimate gravitational object. We understand that a black hole is defined by its event horizon, the boundary that seals its contents from the universe forever, an impenetrable wall from which no messenger can ever escape. And now the paradox comes into full focus. The contradiction at the heart of our modern understanding of gravity. We see the evidence of the black hole's influence everywhere. We see stars billions of miles away from a black hole orbiting its unseen center as if it were a normal massive object. We see entire galaxies like our Milky Way held together by the colossal gravitational grip of a supermassive black hole at its core. Its presence is undeniably felt across vast distances. But how? If the singularity, the source of all that mass, is trapped behind the event horizon, how does its gravitational influence project out into the rest of the universe? If gravity is the curvature of spacetime, as Einstein taught us, how does the information about that curvature get out? The messenger of gravity, whatever it may be, would have to travel from the black hole's center to the outside world, but no messenger can escape. The prison wall is perfect. The warden is the speed of light. Yet the prisoner's command is heard across the cosmos. The black hole's gravity reaches out from beyond its inescapable cage. This is the central mystery, the paradox of the black hole's ghost. It is a puzzle that pits Einstein's theory of gravity against itself, and solving it will force us to question the very fabric of spacetime and the fundamental nature of information itself. The secret of how a black hole communicates its gravity is locked behind the most extreme frontier in the universe, and to find it we must venture where the old rules no longer apply. To solve a cosmic paradox, we must first abandon a human intuition. We must let go of the idea of a surface, a wall, a physical thing. The event horizon of a black hole is none of these. It is something far more profound, far more absolute. It is a frontier in the fabric of reality itself, a place where the universe changes its fundamental rules. Imagine you are standing on the edge of a cosmic waterfall, a cascade not of water, but of space-time itself. Upstream, the current is gentle, navigable. You can move freely in any direction you choose, but as you drift closer to the falls, the current quickens. You have to paddle harder, just to stay in one place. There is a line, a shimmering, invisible demarcation in the flow. Cross that line, and the current itself moves faster than you could ever swim. It is not a failure of your strength or your vessel. It is a simple, brutal truth of the river. From that point on, all paths lead down. This is the event horizon. It is the point where the waterfall of space-time plunges inward at the speed of light. The ultimate speed limit of the cosmos becomes the velocity of the current. This is why nothing, not even a beam of pure light, can retreat. To escape would require moving backward through space-time faster than light itself, an impossibility woven into the deepest logic of the universe. The laws of physics themselves become the prison walls. So when we speak of escape velocity, we are not describing a simple speed. On Earth, a rocket must reach 11 kilometers per second, a colossal achievement of power breaking the planet's hold. From the Sun, it is more than 600 kilometers per second, a demand for even greater, more violent propulsion. But these are numbers we can comprehend, goals we can engineer. They are challenges of force against force. The black hole presents a challenge of a completely different order. It is a challenge of geometry. As you approach the horizon, the escape velocity climbs relentlessly. It is a measure of how steeply space-time is curved, how deep the gravitational well has become. Thousands, then tens of thousands of kilometers per second. The energy required to pull away becomes astronomical. The path to freedom becomes a near vertical climb against an impossible gradient. And then, at that one specific distance from the center, the threshold is reached. The escape velocity becomes 300,000 kilometers per second. the speed of light. At this boundary, the universe makes a chilling declaration. It decrees that every possible future trajectory now points inward. There are no more paths leading out. Space is flowing into the black hole faster than you can move through space. You are a swimmer in a current, too swift an astronaut on a walkway, moving backward faster than you can run forward. It's a quiet geometric defeat. You would not necessarily feel a thing as you crossed it. No bump, no spark, no signpost declares you are now leaving the known universe. It would be the most tranquil and the most terrifying moment imaginable. A silent transition from a place of possibility to a place of certainty. The certainty of a one-way journey to the center. This is the nature of the cage. It is not made of matter or energy. It is made of distorted space-time, an invisible, inescapable vortex. And this brings us back to the great enigma. If this cage is so perfect, if its defining rule is nothing gets out, how does its gravity, how does this prisoner locked in a cell of its own making, project its influence across the cosmos? How does it hold on to stars, swirl accretion disks into fiery maelstroms and dictate the fate of entire galaxies? If no messenger can emerge, how is the message of its immense gravity delivered? The answer requires us to perform an even deeper kind of surgery on our intuition. We must stop thinking of gravity as something a black hole sends out. Gravity is not a signal, not a particle, not a message dispatched from the singularity. Gravity is not an action, it is a condition. It is the shape of the universe in the vicinity of the black hole, a permanent, static, unyielding feature of space-time's architecture. Think of the Sunday. Its gravity holds our Earth in a delicate, life-giving orbit. But this gravitational hold is not a rope, not a beam that is constantly being transmitted from the Sun's core. The Sun's immense mass, simply by existing, has created a depression in the fabric of space-time, a vast, gentle basin like the impression a heavy ball makes on a stretched sheet. Earth is not being pulled. Earth is simply following the straightest possible path through that already curved space. We are rolling along a pre-existing contour in the cosmic landscape. If the Sun were to vanish instantly, this distortion wouldn't vanish with it. The news of its disappearance, the flattening of space-time, would ripple outward. A gravitational wave traveling at the speed of light. It would take 8 minutes for the Earth to learn it was suddenly adrift. Now take that principle and apply it to the formation of a black hole. Imagine a colossal star hundreds of times the mass of our Sun. Throughout its long life, its immense mass has been warping space-time around it. It has already carved out a deep gravitational well. Planets may orbit it, light from distant galaxies may bend as it passes by. Its gravity is already a dominant feature of its cosmic neighborhood. Then its fuel is spent. The outward push of fusion ceases. The star's own gravity, for so long held in check, wins the final battle. In a cataclysm of unimaginable violence, the star collapses in on itself. The mass is not destroyed. It is compressed, squeezed into a volume so infinitesimally small it beggars belief. What happens to the gravitational field? Does it vanish and then need to be re-emitted? No. The collapse happens inside the star's pre-existing gravitational field. The warp in space-time was already there. The collapse simply makes it deeper. The gentle basin becomes an abyss, a puncture. The curvature becomes so extreme, so severe, that at a certain depth within that, well, the event horizon is born. The point of no return forms like a frost line in the cold geometry of space. But the field, the curvature outside that new boundary remains. It is a fossil, a ghost, a permanent monument to the mass that is now lost to the universe. The gravity we feel from a black hole isn't escaping from the singularity. It is the enduring historical imprint of the star that died. The information about the black hole's mass was encoded into the structure of space-time long before the event horizon ever formed. And that structure, that shape, is what we call gravity. It doesn't need to be refreshed or updated by messages from within. The black hole's mass holds space-time in a specific contorted shape. That shape dictates how everything nearby moves. It is a static field, a silent testament. This is why a black hole that formed billions of years ago can still hold a galaxy in its thrall today. The warp in space-time is self-sustaining, a feature of the universe as fundamental as time itself. We can begin to see the illusion for what it is. We ask, how does gravity get out? The question assumes gravity is a traveler, something that needs to make a journey. But it is not the traveler, it is the landscape. It is the very ground upon which all journeys in the cosmos must take place. It is the set of tracks that all matter and energy are forced to follow. The black hole is merely the architect of those tracks. An architect now permanently sealed within its own most extreme creation. This understanding resolves another deep mystery of black holes, the so-called no-hair theorem. This profound principle of physics states that a stable black hole is astonishingly simple. It is defined by only three properties, and three properties alone: its mass, its electric charge, and its spin or angular momentum. That is it. A black hole formed from a collapsed star is indistinguishable from one formed from 1 trillion tons of collapsed encyclopedias or a universe full of discarded spaceships. All the complexity, all the information, all the richness of the material that fell inside is gone forever. The black hole has no memory of what it ate. It has no hair, no complex features to betray its history. How can this be? Because the only things that can create a permanent, stable, long-range field in the universe are mass, charge, and spin. These are the only properties whose influence is imprinted on the external space-time geometry. The shape of the space-time outside the event horizon only carries information about these three fundamental quantities. All other details, the chemical composition of the star, the color of the spaceships, are trapped inside the horizon. The information is lost because it has no way to influence the external geometry. The gravity field outside is a pure, simple echo of the total mass within. A clean, unambiguous distortion that tells you only one thing: how much matter is trapped inside. The mystery of how gravity gets out is inverted. We see now that it is the only thing that is never truly trapped. It is the prison itself. Let's reimagine our journey toward the abyss with this new clarity. From light years away, your spaceship's computer detects a gravitational anomaly. It's not sensing particles streaming from a source. It is sensing the local topology of the universe. It registers a steepening gradient, a slope in the fabric of reality. Your ship is not being pulled. Its inertial guidance system is simply following the straightest possible line through a curved environment. That line just happens to lead toward a central, massive object. The gravitational field is a map that was already drawn. You are simply reading it with your ship's trajectory. As you get closer, the curvature becomes more pronounced. Light from distant stars begins to bend around the unseen mass, creating strange arcs and rings. This is gravitational lensing. Again, nothing is being emitted from the black hole to cause this. The light is simply following the contours of the pre-existing warp. The black hole is a silent lens, its properties defined by the mass that sculpted it into being. The photons of light are explorers charting the depths of the well. Their bent paths are the evidence they bring back. Finally, you reach the vicinity of the event horizon, the point of no return. The waterfall of space-time is now a raging torrent. But the gravitational influence you feel, the intense tidal forces threatening to tear your ship apart, are not new. They are not some fresh signal being sent from the singularity. They are the ultimate, most extreme expression of that same static curvature that you first detected light years away. The field was always here, extending from the location of the mass all the way out to infinity. You have simply traveled to the place where that field becomes absolute, where the map's contours become a sheer vertical cliff with no bottom. The paradox dissolves not in a flash of light, but in a quiet shift of perspective. Gravity does not need to escape a black hole, because gravity is the eternal distortion in space-time caused by the mass within the black hole. It is the context, not the content. It's like asking how a canyon escapes from the river that carved it. The question makes no sense. The canyon is the lasting evidence of the river's work. The gravitational field is the lasting evidence of the collapsed star's mass. It is a scar on the cosmos, and space-time has a very, very long memory. But science is never quite so simple. Our story so far has been told in the language of Einstein of general relativity, a beautiful classical theory of smooth curves and flowing geometry. But there is another language to describe the universe, the chaotic probabilistic language of quantum mechanics. And in that language, forces are not just fields, they are mediated by particles. The electromagnetic force is carried by photons, the strong nuclear force by gluons, and the force of gravity should, in theory, be carried by a particle called the graviton. This seems to throw us right back into the heart of the paradox. If gravity is a conversation held with gravitons, how can a black hole speak? How can these messenger particles escape the inescapable horizon? Here we stand on the absolute frontier of human knowledge, a place where our two greatest theories of reality refuse to agree. We have no complete tested theory of quantum gravity, but the theoretical frameworks we do have offer tantalizing clues. They suggest that the gravitons responsible for a static gravitational field are not real particles in the conventional sense. They are virtual particles. Virtual particles are a strange and wonderful feature of the quantum world. They flicker in and out of existence, borrowing energy from the vacuum for fleeting moments. They are not bound by the same rules as real particles. They can, in certain mathematical formulations, exist outside the normal constraints of space-time. They don't need to travel from the singularity to the outside world. They can be thought of as manifestations of the field itself, a quantum expression of the static, unchanging geometric warp. So in this view, the question of escaping becomes meaningless for a different reason. The virtual gravitons that constitute the field are not leaving the interior. They are simply a quantum description of the state of space-time outside. This is a profoundly difficult concept, a place where language and intuition truly fail us. It is the bleeding edge of theoretical physics, a hint that the reality of a black hole is even stranger than Einstein's theory suggests. It may be that the space-time we see is just a classical approximation, and that underneath there is a seething quantum foam of information. In this view, the black hole's gravity isn't a ghost of a dead star. It is a complex quantum state inextricably linked or entangled with the space-time outside of it. The two are part of the same system. One cannot exist without the other. There is no inside and outside. There is only the whole, so we are left with two pictures, one classical, one quantum, both pointing to the same truth. The black hole does not broadcast its gravity. Its presence is a fundamental condition of the space around it. Whether you see that condition as a geometric scar left by a collapsed star or a complex quantum state woven into the vacuum, the conclusion is identical. The influence is already there. Nothing needs to get out. The question itself was a red herring, a trick of our own flawed perspective. We imagined gravity as an actor on the stage of space-time, but we have discovered that it is the stage itself. The black hole, then, is a purer expression of this truth than any other object. It is what remains when you strip away all of matter's complexities, when you burn off its chemistry, its texture, its light. What is left? Just its raw influence on the shape of reality. just its mass, its spin, its charge. A black hole is not an object that has a powerful gravitational field. A black hole is a powerful gravitational field. It is the ultimate endpoint of matter, a transition from substance to pure geometry, a knot in the fabric of the cosmos so tight that it can never be undone. The universe cannot forget its presence because its presence is now a permanent feature of the universe's own form. The prison and the prisoner's shadow are one and the same. We have been asking the wrong question. For 2 acts we have pursued a phantom, a cosmic criminal. We imagined gravity as a clever fugitive, a spectral messenger that somehow slips the bonds of a prison that holds even light. We have been detectives at a cosmic crime scene wondering how a message gets out of a sealed room. But the truth is more profound, more elegant, and far stranger. The revelation that solves this riddle does not lie in finding some secret passage out of the black hole. It lies in understanding that gravity was never inside to begin with. To grasp this, we must perform a revolution in our minds. We must let go of an idea we learned as children, an intuition so deep it feels like common sense. We must abandon the notion of gravity as a force, an invisible rope pulling objects toward one another across empty space. This was Newton's magnificent vision, a vision that builds bridges and sends probes to distant worlds with breathtaking accuracy. But in the presence of the ultimate at the edge of infinity, Newton's beautiful illusion shatters. Here we need a new language, a new architecture for reality. We need the universe as imagined by Albert Einstein. He gave us a new protagonist, a new medium for cosmic drama. Not empty space, but a dynamic 4-dimensional fabric. He called it space-time. It is not a passive stage upon which the universe performs. It is an active, flexible, responsive entity. It can be bent, warped, twisted, and compressed. And it is this bending, this warping of the very geometry of existence that we feel and call gravity. Imagine a vast, tightly stretched rubber sheet suspended in the dark. This sheet is our universe, the fabric of space-time. It appears flat and featureless, extending in all directions. Now take a heavy bowling ball and place it in the center. The ball is our sun, a massive star. What happens? The sheet immediately sags under the weight. It creates a smooth, sloping depression, a gentle well in the fabric. This depression, this curvature in the sheet is the sun's gravity. It is not a force the ball is sending out. It is not a signal beamed into the surrounding space. It is a persistent, static feature of the landscape itself, a consequence of the ball's mere presence. Now roll a small marble, our Earth, onto the sheet. It doesn't travel in a straight line. It is guided by the curve circling the central depression. The marble is simply following the most direct path available to it through the warped geometry of the sheet. It feels a pull toward the bowling ball, but there is no invisible tether connecting them. There is only the shape of space. The marble is free, but its path is dictated by the geometry. Gravity is not an action, it is a condition. It is the architecture of the cosmos. This is the first part of the revelation. Gravity is not a messenger that needs to travel. It is the landscape. But what happens when our star dies a spectacular death? What happens when it collapses under its own immense weight? In our analogy, imagine our bowling ball suddenly impossibly shrinking, compressing into a point of infinite density. It becomes so dense it punches a hole through the rubber sheet, a tiny bottomless puncture, a point of no return. This is our black hole, the singularity. The bowling ball itself, the original mass, is now gone from our sheet. It has exited this dimension of space-time. And here is the heart of the paradox and its solution. The ball is gone. So what happens to the dent it made? Does the rubber sheet snap back to being flat? No. The deep sloping well that the ball created remains. The curvature that was established when the star existed is still there, imprinted permanently on the fabric of space-time. The gravitational field of a black hole is a ghost. It is the enduring legacy of a star that once was. It is a fossil, an echo in the geometry of the universe. It is the memory of mass, and this memory dictates everything. When you look at a black hole, you are not seeing an object that is actively pulling things in. You are witnessing a static, pre-existing warp in reality, a drain in the cosmic ocean that was carved out long ago. The gravity doesn't need to escape the event horizon because the gravity is the shape of space-time outside the event horizon. It is an ancient artifact of the star's life, not a product of its death. The information about the star's mass, its fundamental property, was encoded into the structure of space-time as the collapse occurred. The event horizon then formed like a veil hiding the remnant but not erasing its influence. Think of it like a footprint in wet cement. A giant steps into the soft mixture, leaving a deep impression. Then the cement hardens, freezing that impression forever. The giant can walk away, vanish entirely. But the footprint remains. It is now a permanent feature of the ground. Anyone walking by will stumble into it, be guided by its shape. They will react to the presence of the giant, even though the giant is long gone. The black hole's gravity is that hardened footprint. The event horizon is the moment the cement set. The mass is gone from our view, but its impression is indelible. This is why the question, "How does it get out?" is a flawed premise. It's like pointing to the dent in the rubber sheet and asking, how does the dent escape from the hole at its center? The dent doesn't need to escape. The dent surrounds the hole. The influence is already out here with us in our universe. The mass of the collapsed star dictates the geometry of space-time that extends from the event horizon infinitely outwards. Its presence is felt not because of a continuous broadcast, but because of a permanent, unyielding alteration to the universe. This concept separates two crucial ideas, the static gravitational field and dynamic gravitational waves. Our rubber sheet analogy helps here too. A stationary bowling ball creates a static, unchanging depression. This is the gravitational field of a non-rotating, non-feeding black hole. It just sits there, an unchanging feature of the cosmos. But what if you were to drop another bowling ball onto the sheet? Or if two were to spiral into each other and collide? The sheet would shudder. Ripples would race outwards from the disturbance. These ripples are gravitational waves. They are dynamic changes in the curvature of space-time. They are news broadcast at the speed of light. They carry information about violent, accelerating cosmic events. And if such a disturbance were to happen inside the event horizon, those ripples would never get out. Any news from within the black hole, any change to the mass, any vibration or explosion would be trapped forever. The space-time inside is falling inwards, faster than the ripples can propagate outwards. The cosmic news broadcast is silenced for all eternity. But the static pre-existing field, the original great dent, it remains serene and unaffected, a silent testament to the mass locked within. The black hole's gravitational whisper to the universe is eternal, but any new screams from within are swallowed by the abyss. So we have a universe where gravity plays two distinct roles. It is both the silent, unchanging architecture of space and the dynamic messenger of cosmic upheaval. The gravity of a stable black hole is the former. It is the quiet, foundational geometry. It is not a particle, a graviton trying to race out past the event horizon. If it were, it would fail just as a photon does. Instead, the theory suggests that the source of the gravitational field is the total mass energy contained within a region. Before the collapse, the star's mass energy created a field. As it collapsed, that field intensified, deepened. The event horizon formed within this already established field. The cause is now hidden, but the effect is manifest. It's a breathtakingly counterintuitive idea. The black hole's dominion is not an active, ongoing projection of power. It is a passive, permanent state of being. It has so fundamentally altered the terrain of reality around it that the universe has no choice but to obey its contours. Orbits are not a response to a continuous summons from the singularity. They are the natural paths of objects navigating a distorted landscape. A planet orbiting a distant black hole is like a blindfolded person walking on what they believe is a flat plane, only to find themselves walking in a circle guided by a vast circular valley they cannot see but can only feel. They are not being pulled. They are simply following the only path laid before them. This changes our perception of the black hole itself. It is not merely a cosmic vacuum cleaner, an object of immense density. It is a place where the distinction between object and space dissolves. The black hole's mass and its gravitational field are inextricably linked. One is the author, the other is the story written into the universe. We cannot see the author, for they are locked behind the horizon, but we can read the story because we are living within its pages. The text is written in the language of curved space and altered time. This principle is fundamental to our cosmos. Every object with mass, including your own body, imprints a tiny, imperceptible curvature onto space-time. You are not just in the universe, you are shaping it. A black hole is simply the most extreme expression of this universal law. It is mass taken to its ultimate conclusion, and the result is a permanent scar on the fabric of reality. A region of space-time so profoundly warped, so deeply curved, that it has effectively seceded from the rest of the known universe. It has folded in on itself, taking a piece of the cosmos with it, but the furrow it ploughed during its formation remains behind. That is the gravity we feel. That is the influence that holds galaxies together. It's the ghost in the machine, the echo of creation. We have been searching for a messenger escaping from a sealed fortress, but we've discovered the truth is far more profound. The fortress itself is built into the landscape of the world. Its existence defines the ground everyone walks on. Its influence doesn't need to escape. Its influence is the very world outside its walls. The paradox has vanished, replaced not by a simple answer, but by a deeper, more elegant understanding of reality itself. Gravity is not a prisoner of the black hole. Gravity is the black hole's eternal, unyielding grip upon the cosmos. Imagine for a moment we could perform the ultimate cosmic magic trick, an act of impossible physics, a violation of the universe's most sacred laws. Imagine we could reach into the heart of a galaxy and with a single silent command cause a supermassive black hole to simply vanish, not explode, not evaporate over trillions of years, but in one instant to be utterly expunged from the fabric of reality. One moment, a monster of 4 million solar masses is holding the Milky Way together. The next, a perfect featureless void. An absence where a singularity once reigned. What would you see? What would you feel from our vantage point, 26,000 light-years away on Earth? The answer is nothing. Absolutely nothing at all. The stars orbiting the galactic center would continue their elegant, frantic dance. They would still follow their paths around a point of invisible, immense gravity. The light from a tortured star caught in its final moments at the event horizon would continue its long journey toward us, a postcard from a ghost. For 26,000 years, the universe would pretend that nothing had changed. The black hole's gravitational influence would remain a phantom limb of the cosmos. It would persist as a stubborn, undeniable fact of our local space-time, a fact that from our perspective is now a profound lie. This isn't just a delay in our receiving the news. It is a fundamental statement about the very nature of gravity itself. The universe has a speed limit, and it is absolute. That limit is the speed of light, and it applies not only to light, but to causality itself. It governs the propagation of any effect, any change, any information whatsoever. The announcement of the black hole's impossible demise is now in transit. It is not a particle. It is not a form of light. It is a wave of pure geometry, a shock front of sudden expanding flatness. For millennia, it journeys across the interstellar void, a silent, invisible tremor in the very essence of space and time. It travels at precisely the same velocity as the last photon that ever escaped the region, the ghost of the black hole's light and the ghost of its gravity racing side by side. This traveling disturbance is what we call a gravitational wave, but this one is unlike any we have ever detected. It is not a ripple from a collision, a chirp from a violent merger. It is a wave of release, a tsunami of cosmic tranquility. As this wave expands, it carries with it a simple, devastating message. The anchor is gone. The great central weight has been lifted. The cosmic mattress, which had been depressed into a bottomless well, is snapping back. But it does not snap back all at once. The information that the weight has been removed can only travel so fast. And so a wave of uncurving space-time propagates outward. For the star systems it has not yet reached, the black hole is still there. Their orbital paths are still dictated by its immense phantom mass. Their reality has not yet been updated with the new truth. They exist inside a bubble of old information, a preserved memory of a dead gravity. Then the wave arrives. It sweeps over a star system that had been in a stable 1,000-year orbit. And suddenly the track on which it runs disappears. The curvature that was holding it in its gravitational embrace vanishes. The star, no longer feeling the pull of a central mass, is abruptly flung into space. It now obeys Newton's first law of motion with sudden, terrifying obedience. It will travel in a straight line, a newly liberated rogue, a cosmic orphan. It continues on a trajectory tangential to the last point of its orbit. An entire star system moments ago, a model of gravitational order, is now chaos. Planets are unmoored from their sun. Moons drift away from their planets. An architecture of elegant orbits built over billions of years is dismantled in an instant. This wave of erasure continues its relentless light-speed journey. It is a shockwave of nothingness, dismantling the galaxy piece by piece. An entire spiral arm, once gracefully pinned to the galactic core, is set adrift. Its collective gravitational memory is wiped clean, and 26,000 years after the black hole's disappearance, the wave reaches us. It would not be a violent shudder, like the merger of two neutron stars. It would be something far more strange, more fundamental. The Earth would suddenly cease to orbit anything beyond the Sunday. Our entire solar system would be released from its grand spiraling path around the galaxy. We would become an interstellar wanderer, cast out into the intergalactic darkness. The night sky would transform over millennia, the familiar constellations warping and dissolving. We would have received the telegram from the heart of our galaxy. A message that took 26 millennia to arrive, informing us that our gravitational anchor had been gone all along. This thought experiment, as impossible as it is, reveals the crucial secret. It forces us to confront the profound difference between two kinds of gravity. The first is the gravity we live in every day, the constant, unchanging field, the persistent curvature of space-time created by a massive object. This is what Albert Einstein called the static field. Think of a heavy ball resting on a stretched rubber sheet. The dent it creates is its gravitational field. The dent doesn't need to constantly send out signals to tell the sheet it's there. Its presence is the shape of the sheet. A marble rolling nearby will follow the curve created by the ball. It isn't pulled by a mysterious force reaching out from the ball. It is simply following the straightest possible path through a curved space. The curvature is the instruction. The geometry is the gravity. The black hole's gravitational influence is exactly this. It is a permanent static feature of the space-time geometry outside its event horizon. It is a fossilized imprint of its immense mass etched into the universe. This is the answer to our central question. Gravity does not need to escape the black hole, because the gravity we feel is not a particle or a wave being emitted from inside. It is the space-time outside. It is the cosmic landscape. The event horizon is a one-way membrane for matter and for light. But the gravitational field, the curvature of space-time itself, was generated as the star was collapsing before the event horizon even formed. That curvature extended outwards, and it remains there, a silent, enduring testament to the mass trapped inside. The information about the black hole's mass is not trapped behind the horizon. It is encoded in the very shape of the space you are in right now. It is a constant, ambient truth. But then there is the second kind of gravity, the dynamic, changing kind. This is what happens when you disturb the field. If you were to suddenly lift the heavy ball from our rubber sheet, the sheet would not instantly become flat everywhere. A ripple of returning flatness would propagate outwards from the center. That ripple, that traveling disturbance in the shape of the sheet, is a gravitational wave. It is a message that says the source of the curvature has changed. This is the crucial distinction. A static field is the established architecture of space-time. A gravitational wave is the news of a renovation. The black hole sitting silently at the center of the galaxy is just architecture. It doesn't need to send any messages to hold the galaxy in its grip. The shape of space-time is doing all the work. It is a constant state. But if that black hole were to merge with another, or in our thought experiment to vanish entirely, that constitutes a change, a dramatic, violent renovation, and the news of that change must propagate outward, not as a beam of light but as a shudder in the fabric of reality itself, a gravitational wave, a cosmic bulletin announcing a new state of affairs. This isn't just a beautiful theory, it is an observed reality. We cannot make a black hole vanish, but the universe provides us with something almost as dramatic: the collision and merger of two black holes. For billions of years, two colossal black holes orbit each other in a death spiral. Their individual static fields combine, twisting space-time into a complex rotating pattern. As they draw closer, they move at unimaginable speeds, approaching the speed of light. They are stirring the fabric of space-time into a violent storm. This is no longer a static situation. The gravitational field is changing moment by moment. This rapid cataclysmic change sends powerful rippling waves of gravity outward. The architecture of space-time itself is oscillating, ringing like a colossal bell. In the final fraction of a second, they merge. Two event horizons become one. Two singularities become one. The new, larger black hole is initially a distorted, quivering mess. It quickly settles down, shedding its instabilities, as one final, powerful burst of gravitational waves. And then, silence. The storm subsides. The new, more massive black hole is now a single, stable entity. It has a new static gravitational field, a new permanent dent in the cosmos. The ringing fades and the new architecture is set. On September 14th, 2015, we felt that storm. A gravitational wave born from a collision 1.3 billion years ago washed over the Earth. It was a message from the distant past, a message of cosmic violence and creation. It stretched and squeezed our planet by less than the width of a proton. But the exquisitely sensitive detectors of the Laser Interferometer Gravitational Wave Observatory, LIGO, registered this infinitesimal tremor. For the first time, we heard the sound of space-time itself. The signal was a chirp rapidly rising in frequency and amplitude. It was the sound of two black holes spinning faster and faster, closer and closer, followed by the ring down of the newly formed black hole settling into its calm final state. And here is the most profound confirmation of our thought experiment. By comparing the arrival time of this gravitational wave with any light or particles emitted by the same event, we can measure the speed of gravity. Through multiple observations of merging neutron stars where we can see the light and feel the gravitational waves from the same cataclysm, we have made the measurement. The verdict is in. The speed of gravity is the speed of light. Einstein's century-old prediction was not just correct, it was perfect. The news of a change in a gravitational field travels at light speed, which means that the static field itself, the unchanging curvature, requires no messenger at all. It is simply there. This reveals the black hole in a new light. It is not a cosmic vacuum cleaner, actively sucking things in. It is a passive feature of the cosmic topography, an impossibly deep, steep well in the fabric of space-time. Anything that wanders too close simply follows the curve of that well to its inevitable fate. The black hole doesn't have to do anything. Its existence is the action. And while the event horizon famously hides all complexity within the static gravitational field it produces, outside is elegantly simple. Physicists have a beautifully blunt phrase for this. A black hole has no hair. This means that once a black hole forms and settles down, all the information about what it was made of is gone forever. It doesn't matter if it was formed from a star of pure hydrogen, or a planet of solid diamond, or a billion spaceships. The end result is identical. The black hole is defined by only three quantities, three hairs. Its mass, which dictates the depth and scale of its gravitational well. Its spin or angular momentum, which describes how much it twists the space-time around it. And its electric charge, though for most astronomical black holes this is effectively zero. That is it, mass and spin. This is all the information that is encoded in that vast, static gravitational field. It is the black hole's permanent, unchanging signature upon the universe. It doesn't need to shout its presence across the cosmos. It doesn't need a messenger to escape its own inescapable grip. Its gravity is a silent, structural truth, an indelible feature of the geometry of everything everywhere outside its dark edge. It is a constant ambient whisper that tells us not what is happening now inside, but what has already happened. A memory of collapse written into the shape of forever. We have arrived at the final threshold of our journey, at the very edge of the ultimate question. For hours we have traveled through a cosmos of paradoxes. We have stared into an abyss that devours light itself, and yet a persistent whisper has followed us through the void, a question that seems to break the very logic of the universe. If nothing, not even the fastest thing in existence can escape. If the event horizon is a perfect one-way door to oblivion, how do you feel the black hole's presence right now? How can its gravity reach across space to hold stars in orbit? How can a message be received from a prison that lets no messenger out? This is the final mystery, the central enigma. And its solution does not lie in some exotic particle. It does not require us to imagine gravity as a privileged messenger, a ghost that can walk through the most absolute of walls. The answer is far more profound, far more elegant. It requires us to tear down our most basic assumptions, to rethink not what gravity does, but what gravity is. The mistake has been in the question itself. We have been asking the wrong thing all along. We ask, how does gravity escape? But that question is built on a flawed foundation. It imagines gravity as something sent from the singularity. A signal, a particle, a wave fired from the heart of the abyss. A desperate message in a bottle thrown against an impossible tide. This picture is wrong, utterly and fundamentally wrong. Gravity is not a messenger struggling to break free from chains. It doesn't have to escape because it was never trapped. It isn't in the black hole at all. Gravity is the black hole. It is the shape of the prison felt far beyond its walls. To understand this, we must go back to the moment of creation, to the cataclysmic death of a colossal star. Imagine a star hundreds of times more massive than our Sun. For millions of years it burns with unimaginable fury. Throughout its life, its immense mass bends the space around it, like a heavy ball on a vast cosmic membrane. This curvature, this deep well in the fabric of reality, is its gravity. It is a permanent feature of its existence in the universe. Moons and planets, if they existed there, would follow these contours. They orbit not because they are pulled by a rope, but because they are rolling along a valley in the shape of space-time. The star's gravity is already present, extending for light years. Now the star begins to die. Its nuclear furnace sputters. The outward push of fusion fails against the inward crush of its own mass. The collapse begins, a catastrophe of cosmic proportions. In a fraction of a second, the star implodes. Its matter is squeezed into an impossibly small volume. Density skyrockets towards infinity. As the matter compresses, the curvature of space-time deepens. The valley becomes a canyon, then a chasm, then an abyss. The gravitational influence at its surface intensifies beyond measure. The escape velocity climbs higher and higher, thousands of miles per second, tens of thousands, and then the critical threshold is crossed. A point of no return is born from the collapsing star stuff. A mathematical surface, an ethereal sphere appears, the event horizon. But look carefully at what has happened. The event horizon forms inside the pre-existing gravitational field. The immense sprawling curvature of space-time was already there, a legacy of the star that lived for millions of years. The event horizon doesn't erase this external geometry. It simply seals off the crushed remnant of the star from our view. Think of it this way. You place a massive cannonball on a stretched rubber sheet. It creates a deep, wide depression that you can see and measure. Now you carefully lower a small, opaque dome over the cannonball. The dome rests inside the depression, hiding the ball from sight. Does the depression in the sheet vanish? Of course not. The curvature, the shape of the rubber sheet remains. You can still roll a marble nearby and watch it orbit the hidden object. The dome is the event horizon. The cannonball is the singularity. The depression in the sheet is the gravity. The gravity isn't trying to get out from under the dome. It is the permanent shape of the fabric caused by the mass within. The event horizon is a one-way gate for things trying to get in. A marble that rolls too close will fall under the dome, lost forever. But the gravitational field, the warped geometry, is a constant. It is a fossil, a permanent scar left on the universe, a testament to the mass that was once a brilliant star. The black hole's gravitational field is the shape of space-time itself, a shape that was forged during the violence of its birth. And that shape holds the complete story of the abyss, or rather, the only parts of the story the universe allows it to tell. When the star collapsed, it was a thing of immense complexity. It had mountains of iron oceans, of helium, storms of plasma. It had magnetic fields, spectral lines, a unique chemical signature, a whole universe of information. All of it fell inward beyond the newly formed event horizon, and all of it was erased, utterly and permanently. The universe, in its most profound act of cosmic censorship, wipes the slate clean. This principle is known with a stark and beautiful simplicity as the no-hair theorem. A black hole, once it settles, has no hair. No complex features, no mountains, no memories of what it once was. All of that intricate detail is gone. It is the ultimate minimalist object. It is defined by only three properties, three fundamental numbers that dictate the entire shape of its prison: mass, angular momentum, and electric charge. That is all. The first and most important is its mass. This is the primary author of its gravitational story, the total amount of matter and energy that fell into the abyss. It dictates the sheer depth and breadth of the space-time curvature. A more massive black hole creates a deeper, wider gravitational well. Its influence stretches further across the cosmos. Its event horizon, the circumference of no return, is larger. When a star, a planet, or even a particle of light falls in, its information is lost, but its mass energy is not. It is added to the total ledger of the black hole, and the curvature of space-time outside adjusts instantly. The gravitational well deepens just a little more. The change is not a signal sent from within. The change is a seamless, instantaneous reconfiguration of geometry. Space-time itself shifts, accommodating the new total mass. The universe updates its map of reality without sending a messenger. The second number is angular momentum. The black hole's spin. The original star was almost certainly rotating. As it collapsed like an ice skater pulling in her arms, that rotation sped up to unimaginable speeds. This spin is not lost. It is inherited by the black hole. And it does something extraordinary to the fabric of space-time. It doesn't just curve it, it twists it. The black hole drags the very geometry of the universe around with it. This is not a metaphor. It is a physical reality. Space and time themselves are caught in a cosmic whirlpool, an effect known as frame dragging. Close to a spinning black hole, there is no such thing as standing still. Space itself is flowing faster than the speed of light. You are compelled to move with it to join the vortex. This twisting of space-time changes the shape of the gravitational field. It alters the orbits of stars and the paths of light rays. It creates a region called the ergosphere just outside the event horizon, a place where energy can, under special circumstances, be extracted. The spin, this second piece of its identity, is encoded forever in the swirling vortical geometry of the space that surrounds it. It is a dance choreographed into the architecture of reality. The third and final number is its electric charge. If the collapsing star had a net positive or negative charge, the black hole will inherit it. This is less common in the cosmos, as stars are typically neutral. Matter in the universe tends to balance its charges. But if a black hole were to have a charge, it would project an electric field out into the universe. Just like its gravitational field, this electric field is not something that escapes from within. It is a fundamental property of the external space-time geometry, a static field that permeates the space around the object. It is the third and final piece of hair the universe allows. Mass tells us the depth of the well. Spin tells us the twist of the vortex. Charge tells us the electrical tension in the surrounding space. And with these three numbers alone, you know everything. Everything that can be known about a black hole from the outside. Its entire identity, its complete influence on the cosmos is written into the static, enduring shape of space-time beyond its edge. The light from a falling astronaut cannot escape. The radio signals from their transmitter are silenced forever. The intricate patterns of their brain, their memories, their dreams, all that information is crushed and lost to this universe. But their mass is added to the whole. Their angular momentum is bequeathed to the cosmic spin. Their charge joins the final tally. And the external universe registers this donation not as a message but as a subtle change in its own structure. A minute deepening of the gravitational valley. This resolves the great paradox. Gravity is not a force that needs to travel, it is a condition, a permanent feature of the universe's fabric. The event horizon is a boundary for causality, not for geometry. It dictates what events inside can affect events outside, and the answer is none. The singularity cannot reach out and touch you, but the ghost of the star that died to create it, the permanent warp in space-time, left behind by its immense mass, that can hold a galaxy in its thrall for billions of years. So when we look at the center of the Milky Way at Sagittarius A, our own supermassive black hole, and we see stars executing impossibly fast, precise orbits, We are not seeing them dance to a song sung from behind a wall. We are seeing them skate on a frozen, invisible bowl in space-time. A shape that was sculpted billions of years ago. A shape whose existence is independent of the passage of time. It does not need to be renewed or rebroadcast. It simply is. The black hole does not need to tell the universe it is there. Its presence is the universe. It is woven into the very coordinates of space and time. The question was never about escape. It was about understanding the nature of the prison itself. The bars of the cage are not physical matter. The bars are the bent pathways of reality. And we feel them not because a message gets out, but because we are already living within their architecture. This isn't just a cosmic curiosity. It is a fundamental lesson about the world we inhabit. The force that holds you in your chair right now, the Earth's gravity, works on the exact same principle. You are not being pulled by an invisible tether to the Earth's core. You are following a microscopic curve in the space-time around you. A curvature created by the total mass of our planet. The black hole is simply this principle taken to its absolute, most terrifying and most magnificent extreme, where the curvature becomes so severe it folds in on itself, creating a hole in the universe from which nothing can return, but the shape, the influence, the gravity that remains. A silent, eternal monument to the mass that is lost forever. A shadow cast not by blocking light, but by bending the world. Our journey began with a question so simple it felt almost childlike, a paradox that seems to defy the most basic cosmic law we know. If nothing, not even the fleetest particle of light, can escape, how then does a black hole broadcast its immense authority? How does its gravity reach out across the void to command stars, to hold galaxies in a stately spinning embrace? The question itself seems to demand an escapee, a messenger. It paints a picture of gravity as a tireless runner racing out from the heart of the abyss to tell the universe what to do. But we have travelled far from that simple picture. We have ventured beyond the familiar world of forces and particles, of pushes and pulls, into a cosmos far more elegant and strange. The answer we have discovered is not found in an impossible escape. It is found in a profound reimagining of everything. The solution lies in realizing we were asking the wrong question. Gravity does not need to escape a black hole. Because gravity is not a thing in the black hole, it is not a prisoner clawing at the walls of an event horizon. In the cosmos, according to Einstein, gravity is the prison itself. It is the shape of the walls, the curve of the floor, the structure of space-time. The black hole doesn't emit gravity. The black hole is gravity made manifest in its most extreme form. It is a permanent, silent, and immovable warp in the fabric of reality. Imagine the universe not as an empty stage, but as a vast torch sheet. Before the black hole was born in the final fiery collapse of a colossal star, this fabric was relatively flat, serene, uncomplicated. The star in its final moments did not just create an object. It created a feature in the landscape of existence. Its immense mass pressed down upon space-time with unimaginable force, and in its wake, it left a permanent indentation, a bottomless well. This cosmic abyss is what we perceive as the black hole's gravity. It is not a signal that is constantly being sent out. It is a static, enduring condition of the space that surrounds it. Like a canyon carved by a river that has long since vanished, the black hole's influence is a fossil, an artifact of its violent birth. The matter that formed it is gone, locked away behind the event horizon, but the shape it imposed upon the universe remains. Orbits are not paths dictated by an invisible tether pulling from the center. They are the straightest possible lines an object can follow through a universe that has been profoundly curved and distorted. A planet orbiting a black hole is not being held in place by a force. It is perpetually rolling along the slanted rim of this cosmic well, a marble tracing the edge of a great invisible bowl. It is simply following the contours of the space it inhabits. The influence is already there, woven into the geometry of existence. Light itself, the universe's ultimate speedster, is bound by this same geometry. As it skims past the edge, it too must follow the curve. And if it strays too close, the curve becomes a cliff, a sheer drop from which the path forward no longer leads back out into the cosmos. The path itself folds inward, terminating inside the horizon. So the great paradox that launched our investigation dissolves. It was a ghost born from an old way of thinking. Gravity doesn't need to move at the speed of light to escape, because it doesn't need to move at all. It is a constant, a defining characteristic of the universe's architecture, a silent testament to the cataclysm that created this dark leviathan. The black hole's gravitational field is the enduring echo of its formation. This realization does more than just solve a puzzle. It elevates the black hole from a mere cosmic vacuum cleaner, a simple agent of destruction, into something far more profound. It becomes the ultimate laboratory for the laws of nature. Here, in these cauldrons of warped reality, our most cherished theories are tested. They are stressed to their absolute breaking point. General relativity, Einstein's masterwork of gravity and geometry, has passed every test we have thrown at it with flying colours. Nowhere are its predictions more dramatic or more powerfully confirmed than in the silent chaos surrounding these invisible titans. For decades they were purely theoretical predictions, mathematical ghosts haunting the equations of a genius. But now we have seen them. We have witnessed their power. With the Event Horizon Telescope, we have stared into the abyss. We captured the shadow not of the object itself, but of its effect, the silhouette of the void cast against a backdrop of superheated gas. We saw the photon ring light bent into a perfect glowing loop, the final orbit from which escape is still barely possible. It was a vision from the edge of oblivion, a perfect match to Einstein's forecast. And we have done more than see. We have learned to listen. With instruments of breathtaking sensitivity like LIGO and Virgo, we have detected the whispers of the cosmos, gravitational waves. These are not light waves. They are not particles. They are ripples in the very fabric of space-time itself. When two black holes locked in a final frantic dance collide and merge, they unleash a storm in the geometry of the universe. The fabric of reality quakes, stretching and squeezing in all directions. This cosmic tremor travels outward across the universe for billions of years, a silent symphony played on the instrument of space-time. And here on Earth, our detectors, the most sensitive microphones ever built, can sense this vibration, a distortion smaller than the width of an atom. In that faint signal, we hear the story of a cosmic collision. We confirm with astonishing precision the predictions of a theory conceived a century ago by a man with nothing but a pen paper and his mind. We are listening to the sound of gravity, the ringing of space-time itself. These enigmatic objects, once relegated to the realm of science fiction, have become our most vital tools for understanding the universe's fundamental laws. They are the crucibles where we can witness the physics of the impossible. They are nature's particle accelerators, far grander than any we could build. But even as they confirm our understanding, they point toward a deeper mystery. They guide us to the very edge of what we know and perhaps what we can know. For at the heart of every black hole beyond the veil of the event horizon lies a place where our beautiful, elegant theory of gravity breaks down. The singularity, a point of supposedly infinite density of infinitely curved space-time. The equations of general relativity, so powerful everywhere else, give us an answer here that makes no physical sense. Infinity. This is not a description of reality. It is a signpost, a warning flare fired from the depths of the cosmos. It tells us that our theory, as magnificent as it is incomplete. At this single infinitesimal point, the two great pillars of modern physics collide in a paradox that we have yet to resolve. General relativity is the law of the colossal, the smooth, curving architecture of stars, galaxies, and the expanding universe. Its domain is the majestic cosmic dance on the largest of scales. Quantum mechanics is the law of the infinitesimal, the strange, buzzing world of particles, probabilities, and quantum leaps. Its domain is the frenetic, uncertain reality of the subatomic realm. These two theories are triumphs of human intellect. Separately, they are the most successful scientific frameworks ever devised, but they speak fundamentally different languages. They describe two incompatible versions of reality. One is smooth, predictable, and deterministic. The other is chaotic, probabilistic, and fundamentally uncertain. For most of the universe, this is not a problem. Their domains are so vastly different they rarely need to interact. But in the heart of a black hole, they must. At the singularity, an immense galaxy-sized mass is crushed into a space smaller than an atom. Here, the world of the very large and the world of the very small become one. To understand what happens here, we need a new theory, a theory that can unite these two warring descriptions of reality, a quantum theory of gravity, a theory of everything. This is the holy grail of modern physics, the ultimate quest, and the black hole is our guide. It is the cosmic Rosetta Stone. It is the only place in the universe where we know for certain that the secrets of this unification must be written. Physicists around the world are grappling with this challenge. Some imagine that reality is woven from unimaginably tiny vibrating strings whose different frequencies of vibration give rise to all particles and forces. In this view, the singularity is not a point but a fuzzball of strings. Others propose that space-time itself is not smooth and continuous, but is built from discrete, indivisible quantum loops. That at the smallest scale reality is pixelated like a digital image. These are ideas born from minds pushing at the absolute frontiers of thought. They are attempts to write the next chapter in our cosmic story, and to test them to find clues, we look again to the black holes. We wonder what happens to the information that falls past the event horizon. Does it vanish forever, violating a fundamental law of quantum mechanics? Or is it somehow encoded on the horizon's surface like a cosmic hologram? These questions, once confined to theoretical physics, are now being explored with our powerful new telescopes and observatories. Every gravitational wave we detect, every image of a black hole's shadow carries with it subtle clues about the nature of space-time at its most extreme. We are searching for the slightest deviation from Einstein's predictions, the faintest whisper of a new physics that lies beyond our current understanding. So we have come full circle back to a place of profound mystery. But it is a new kind of mystery. Our initial question, born of a simple intuition, has been answered, and in its place stands a deeper, more fundamental inquiry. We are no longer just asking how gravity works. We are now asking what gravity, space, and time truly are. We are asking if the fabric of our reality is all that there is, or if it is an emergent property of something even more fundamental. The black hole, the darkest object in the universe, has become a beacon illuminating the path forward. It teaches us that the universe is not only stranger than we imagine, it may well be stranger than we are capable of imagining. These celestial enigmas are not endings. They are not just cosmic tombs. They are cosmic wombs, places where new questions are born. They challenge us, they humble us, and they inspire us. They remind us that for all we have learned, for all we have discovered, we have only just begun to read the first few pages of the cosmic saga. The darkness is not empty, it is full of answers. And we, a curious species on a small blue world, will continue to look, to listen, and to reach for an understanding of the magnificent, terrifying, and beautiful reality in which we find ourselves. The quest continues,